say we're dealing with an arithmetic sequence because as long as this variable is not an exponent in your sequence, in your formula, it means your sequence is arithmetic. So if we're going to work these out simultaneously, we already have equation 1 nicely here, but from here we have to find out what equation 2 looks like. So we're going to take our SN formula, and then we have to give it values. You see 2a plus n minus 1d. So the easiest one to start with is n, because n you can get it from these two numbers here. Remember, n is equal to where you're ending off minus where you're starting, and then you always have to add 1. You see, so this is like 4 minus 3, which is like 1. 1 plus 1 is a 2. There you go. You see, so that's fine. And then a, we've always said that a is what you get when you throw this value in there. You remember? Don't get a by throwing in 1. You get a by throwing in this value in there. Does that ring a bell? Hello? Anybody home?
It does ring a bell.
Yeah. So with that being said, when you will now look at what's this? When you will now look at, for example, what we're doing now, right? If you're gonna get a, your a value is going to be you throwing 3 into this formula. So you're gonna have x 3 minus 2 squared. 3 minus 2 is just a 1. So 1 squared is a 1. So the value of a is just x. That's fine, right? Now the value of d is any term minus the previous one. So you could even say t2 minus t1 or whatever two numbers you want to use. We can even use, let's just make it generic, t2 minus t1, because, you know, why not? So if you're going to put a 2 where k is, we'll have the x 2 minus 2 squared. This is the first term. I mean, this is the second term, right? The first one, we have to put 1.
Wait.
Okay.
Okay, the first term, right? No, the second term, right? You wrote 2 minus 2.
Yes.
But isn't it supposed to be 4 minus 2?
No, you don't have to worry about using a number that's after the 3. It doesn't matter. As long as these two numbers are one after the other. Because the idea is, remember, with sigma notation, the idea is you'll be dealing with a sequence that starts wherever it starts. But then you adding stuff up, you're not always going to start directly from the very first one. So when you're working at a value of d, whether you use values before this or after this, it's still fine. But for the sake of what you're already used to, let's use T4 and T3. I think that may put you a bit more at ease. So let's change this to a 4. And then the other one, let's change this to let's put a 3 there. Is this better?
Yes, it is.
Okay, so from here we have to be careful. 4 minus 2 is just a 2. 2 squared is a 4. So 4 times x is 4x. Here, 3 minus 2 is a 1. 1 squared is, oh wait, I'd actually made a mistake here. 2 minus 2 was going to be a 0, and then yeah. But anyways, yeah, I think this is better. 3 minus 2 is a 1. 1 squared is a 1. 1 times x is just x. Our value of d here is just 3x. Positive 3x. That's quite interesting. But then at the same time, I'm like, wait a minute. Our value of k is getting squared all the time. So I'm even starting to think to myself, is this even arithmetic or geometric? Now, the one way to maybe test out whether this is going to be arithmetic or geometric, which I think seems like what we could have also have done beforehand. Let's see if it's arithmetic or geometric. Let's lay out a few terms. So here we have the fourth one, the third one. Let's get the second one also. Or rather, let's get the fifth one. Let's see what the fifth term would look like. It's going to be 5 minus 2 here squared. This would be like 5 minus 2, which is 5 minus 2 is a 3. 3 squared is a 9. So this may just end up as geometric after all. Because I think mainly because k is not an yes, but k is subject to an exponent. So I think that's what makes it geometric, because the k, whatever it is, you're gonna square it or do something extra to it, as we can see. But with what we have here, let's see, this would have been t number 5. This would have been t number 4. T number 4 would have been, let's say, 4 minus 2, which is 4. 4 squared. I mean, 4 minus 2 is 2. 2 squared is a 4. So this would have been like 4x. This, we worked it out, it would have been just x. So let's actually see if it's geometric. It could be none. It looks like it's quadratic. And I think I see why it is quadratic. We won't even need, we won't even use arithmetic, or it looks like we can't even use a formula. We'll have to just do it manually because the sequence is quadratic. You see, because there's a term that's x somewhere, and then it's 4x, and then it's 9x. This is clearly quadratic because there's a 1x, 4x, and 9x. So here, all this, we can actually rule it all out. It's not helping us. But this has actually made our life a bit easier, because firstly, we don't even need a formula for this one. The numbers are just too close to each other. So working out adding up two terms is not going to be a difficult task, because we can just see what the first term that was supposed to add is, and then we can see what the second one is supposed to be by just doing it manually. You see, so it's not a difficult task. We can actually just use these. Here, this was t number 3, t number 4, t number 5. And then remember, here we're supposed to add starting from the third one until the fourth one, you see. So we can even see just with our own eyes that if you add this and that, it's gonna be 5x. But our question would obviously be, where's the y even coming from? Because if you're gonna have 5x on this side of the equation, and you're gonna have 5y on the other side of the equation, that's quite interesting. So that's what we're seeing. We're seeing that this whole thing here, it's just boiling down to us having 5x, because 1x plus 4x is just 5x. So we technically have 5x is equal to 5y. You could think of this as equation 2, but it's kind of dumb because, I mean, wow, x can be anything, y can be anything. But then I guess for us to get the exact value of x and the exact value of y for this specific equation, that's where this equation comes in now. This second one. This is just telling us y and x are just going to be the same number, but then we need to find out which one. But then it can, let's say, cut here. Let's see what we can do. So we have one of the equations, and we have the first equation also here. So we have two equations now. Working them out simultaneously, we would have here, what do we have here? We would have here 3. We can actually isolate, what do we want to isolate? It looks like isolating x maybe a bad idea. So
can you scroll a little bit up? Okay, no, you're too far now. Yeah, just there. I just want to write that down.
Mm-hmm.
Okay. How did you get the 5x again?
We said T3 plus T4 because you see this question is asking us to add starting from where K is a 3 until where K is a 4. So when we made K a 3, it gave us this number. When we made K a 4, gave us this number. And this sigma symbol is telling us we should add those. You see? That's what we did.
Okay.
Yeah.
Then carry on.
Yeah. So with that being said, here it looks like it may be, well, there's too many places to put a value of x. So here we could maybe just isolate y instead. Isolating y, well, this is gonna be dumb because here you divide by 5, y is just equal to x. It feels very wrong, but let's just finish and see where we might have fallen off the bus. If you put x where y is, hello?
Oh no, it's fine. Fine.
Yeah, so here we'll have 3x is equal to 1 plus x squared. Everything on one side, you'll have x squared. 1 minus 3 is minus 2, and then there's a plus 1. Factors of 1 that give us a 2, it's just 1 and 1. To get a minus 2, it's like minus and a minus. So here this is just saying x is equal to 1. So if x is a 1, it means y is also a 1. Can you just check the back of the book for this answer? So that we can see if it balances this equation. If this is a 1, this is like 1 squared, which is 1, plus 1, which is 2, plus 1, which is 3. 1 times 3 is a 3. Okay, just check the back of the book what they had. But
The answer is x equals to y equals to 1.
Yeah, then it's fine then. Then it's fine. So that's okay. It was not a difficult question. It just had a weird vibe to it.